So for 4-6, we're going to start this concept where now the coefficient for a quadratic is no longer 1. So in 4-5, it was convenient, right? You always took out a GCF, or the coefficient was a 1, or you had like the sum of squares, and things worked out really nicely. So we always start with the GCF. That's why the asterisk statement is there. Always take out GCFs whenever possible. But when we look at this equation, it's really nice because this is a 1 here. When there's a 1 here, we're going to take a look at 2 cases. The first case, some of you this is brand new for. Some of you, you've definitely seen this before. Okay? But we need to make sure we all understand this because it's not going to go away this year. We think to ourselves, and write this if you need to, what numbers add up to this and multiply to this? That's always the question you ask yourself when there's a 1 in the front. Now again, a lot of you have seen this before, I know that. But this part, and the second part is going to be a little bit new for some. When there's a 1 here, we ask ourselves, what adds up to this and multiplies to this? Okay, the common mistake is to answer with 6 and 1 here. Because students see the 6 and the 1, and they see a 5, 6, 1, 5. That all has a coincidentally same numbers if you have a negative sign there. But 3 and 2 work better, because 3 and 2 add up to 5, and 3 and 2 multiply to give you 6. Okay, so this is the first way we're going to be looking at this. And our factors themselves are simply that. Okay, that's the first scenario. Give it a sec, guys. It's a little bit delayed, the airplay. This becomes, there we go, x plus 3, x plus 2. For part 2, we're going to use what's called AC method. How many of you, show of hands, have factored something like this last year? How would you have gone about factoring? Do you remember how you did it last year? How did you factor something that does not have a 1 here?
So it's a different way, but first we drew it's like we draw an X.
I've seen this method. Okay,
yeah,
got it.
And then Z.
Got it. Okay, we're going to do something similar, but I'm going to make it a little more clear. But yours looks like magic when you do it, right? We're going to do it in a way that makes it more logical, but it's using the same approach that we've learned, actually. So that's a good way to start. Alex?
Quadratic formula.
Okay, good. You can't factor, though, with the quadratic formula. It just gives you the answers, right? The quadratic formula does not give you factors. We know that. It never gives you factors. It gives you roots or answers. But my question is, can we factor this? But we're going to get to the quadratic formula when we find the answers. But for now, we're trying to factor only.
We set it equal to 0, and then you did 15x squared, and then you broke up the 16x into like whatever it was. Like sometimes it was 8 and 2.
But what did you know those were? This is random?
No, you would multiply 15 times 4.
Okay, that's what we're going to do for AC method. Nice. So you've learned AC method, whether you call it that or not. So it's another form of grouping. It's a form by grouping by factoring. So I'm going to teach you guys this real quick. So we're going to start with that idea. So let's take a look here at example 2. And let's take a look here at 15 and 4, right? So 15 times 4, if I look at those values here, I get 60 when I do that. So let's start by listing what AC is. So in this case, AC turns out to be 60. Okay, and it's just 15 times 4, really. That's all we're doing there to get 60. Then we ask ourselves the question, what number multiplies to 60, numbers multiply to 60 and add up to negative 16? So let's go back real quick. Forget the question I even just asked. A minute ago, we said what multiplies to this and adds up to this, right? Again, what multiplies to this and adds up to this. Now we're saying what multiplies to this instead of this. Instead of using this number again for the multiply part, right? That's we used that earlier for the multiply. We're not going to use that. We're going to use AC. But we still ask ourselves what multiplies to this and adds up to the middle term still. So we're still adding up to the middle term. Or we're changing what we're multiplying to. So what multiplies to 60 and yet adds up to negative 16? What 2 numbers?
10 and 6.
Careful. Negative 10 and negative 6. Just be careful because that's a clear, right? This one has to be negatives. I make a point there because anytime you think of what multiplies to give you 60, you got to think of 10 and 6 or 15 and 4 or 30 and 2, but also the negatives of them because we had a negative in the middle. So we start by writing negative 10 and negative 6. These are the values that you're going to use to break up the middle term now. And this is what Regina was speaking about a minute ago. Take the middle term here and break it up into these two values themselves. So I'm going to rewrite this statement here. Let's rewrite it. But instead of writing the middle term the way we see it with a negative 16, I'm going to write it as negative 10x and a negative 6x. So this is really the middle term here. Okay, but we're writing it using these two numbers. I want you to see that it's mathematically okay to do this, right? Just check our numbers here. It makes sense. Negative 10x and negative 6x together become negative 16x. So I'm okay so far mathematically. I'm allowed to do this. Now I ask myself, can I factor this by grouping? AC method will work if you can factor by grouping. And in this case, you can factor by grouping. To factor by grouping, you saw this over the weekend, right? Wasn't this over the weekend, factor by grouping? You watched the video? Yes? I hope. 4 or 5? To factor by grouping, we think of separating it like this. And we think of what comes out of each section. So to the left of the dashed line, what's the GCF? To the left of the dashed line, what's the GCF, Alex? 5x. What does that leave behind? If I take a 5x out of both of these first two terms, I take 5x out. And by taking it out, what do I get?
3x minus 2.
Good. And by taking it out, I'm saying divide by. Remember, you divide by whatever you take out. Remember, whenever you take a GCF out of terms, it's like you're dividing those terms by that GCF. If I took the 15x squared and divided it by 5x, I would get 3x, right? And if I multiplied it back out, wouldn't I get back up to what I have? I would indeed. How about on the right-hand side of the dashed line?
I took out
Negative 2. Look at that. Not just 2. The mistake here would be to take out just a 2. Because students see even, let me just take out the number 2. But if you only take out a positive 2, you wouldn't be left with the same factors as a result. And we remember from grouping method from last night or over the weekend, whenever you watch this video from 4-5, this piece right here has to always be the same as this piece. So had Julia taken out a positive 2, it would have left this behind with negative 3x plus 2, which is the opposite of what we want. So she took out a negative 2 instead. And when you take out a negative 2, look at that. You're left with 3x minus 2. These will always be the same. If they're not, factor by grouping isn't working. If what's in the parentheses is not the same, it means that factor by grouping is not actually working for you. Now, if a factor is in both parts, right, there's 2 parts to this problem now, and 3x minus 2 is in both parts, we can factor it out. And when I factor 3x minus 2 out, I'm left simply with 5x minus 2. And there are my factors. Again, when I take a 3x minus 2 out of both of these, bring it out front, and leaves me with a 5x minus 2 left behind. Okay, this is called factor by AC method. It's simply used when A is not equal to 1, when you have some coefficient in the front here. There's another method, it's called trial and error. You consider all day and try 3 and 5, or 1 and 15. That's pretty much it, luckily for 15, which is nice. But if this coefficient were 12, good luck. You got to try 1 and 12, you got to try 3 and 2, and you got to try 3 and 4, and you got to try 2 and 6. And then you have to try all the possibilities of this, which if this were a number like 30, then you have 1, 3, 5, 6, 10, 15, 30. Look at all those factors. It'd be messy as anything. AC method always gets the answer if it's factorable. If it's not factorable, this will not happen where you have the same thing appearing as both. Alex?
Will you give us something like you just mentioned where it's like 12 and 30?
Sure, absolutely, 100%. And in those cases, you have to use AC method. Because, I mean, you could try trial and error, but on the test, when you run out of time, I'll probably write a statement like, you need to learn AC method. Because trial and error will take you 15 minutes for one problem. So this is kind of what they were doing with the little x. That's actually what you're doing with the little x scheme. I've seen it before. I've never taught it that way. I've taught it this way. But if you're comfortable with that and you can explain your work and you understand what you're doing, it's fine to use that method. Okay, but this is really the same thing. I find this is a more algebraic approach. When teachers teach with like those symbols and stuff, it's fine, it works. But when you get to higher level math where everything's written with all variables, I think you should consider using it this way.
So the AC method, first you multiply the A times the C, right?
Yep, which is right here.
And then what do you do with that answer?
Then you see this answer, and normally you would say, what multiplies to this? And adds up to this, right? That's the normal approach. Now you say, what multiplies to not this, but this? So what multiplies to AC and adds up to B is your new question.
And then you split it.
And once you figure out those numbers, yep, very good, Alex, you split up the middle term into those numbers with the correct linear coefficient. I think I put the steps actually on the latest slides, do I not? Maybe I don't. I go into it in example 2, don't I? Yeah, in example 2 is when I go into it. So let's take a look at examples 1 and 2, because I kind of did a little extra here. I don't usually do those first two. What would this turn out to be? What multiplies to C and adds up to B? What multiplies to negative 28 and adds up to 3? And if you don't know, right, here's what you start with. You start by listing the factors. 7 times 4, 14 times 2, and 28 times 1. Those are all the possibilities, really. Now, since it's negative 28, I've got a plus and a minus somewhere, and you have to start doing the math in your head. Right? 1 is plus and 1 is minus. That's what's going to happen here since it's a negative 28.
X minus 4 times X plus 7.
Yeah. I see that it's the first case, and if we think of a positive 7 and a negative 4 as our options. And again, those multiply to give you negative 28, and they add up to the middle term, which is positive 3. So this gives me my first factor term, x plus 7, and this gives me my second factor term, x minus 4. For those that have gone already on to solving equations in their last class, that's fine, but you're not solving here. Notice the difference? This is factoring. We're going to solve equations in 4-7, 4-8, 4-9, and do a lot more than just that, actually. For now, you are not solving these equations. These are not equations, these are expressions. See the difference? An expression does not have an equal sign. An expression does not have an equal sign.
So back to the AC method.
I'm getting to it right now. Can I? Yeah, I want to move on, and this is an example of that. So we start by multiplying A and C. What would AC be in this problem? What would AC be in this problem? Just by inspection. Good. So I like to write it down. It doesn't really matter that much, okay? But I like to write it down. And now I ask myself the question, what multiplies to AC and adds up to B? What multiplies to AC and adds up to B? So if I don't know what works, I have to think about the numbers that multiply to 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. These are all the options. And because it's negative 24, I know one's going to be negative, one's going to be positive, right, for each of these? I don't know which is right yet, though, so I'm not listing my plus or minuses yet. But I know it's going to be a positive and a negative for sure. Alex, what's it going to be?
Negative 12 and positive 2.
Yeah, and look, everybody, look up, please. Common mistake is to use negative 6 and negative 4, because negative 6 and negative 4 gives you negative 10, doesn't it? But you can't use negative and negative because that will give you a positive here, which it's not. So Alex picked up on, you know what, let's make it negative 12, positive 2, that'll add up to negative 10, and negative 12 and positive 2 gives you negative 24. So negative 12 and positive 2 is going to be our answer here. And that's not our answer, that's going to be the one we're going to use. And that's what we're breaking up the middle term into now. And I'll put it in red. It's going to be a minus or a positive 2x and a negative 12x. Oh, it's a W. You gotta be kidding me. Factor by grouping. So if we're writing steps down, first step is to list AC. Second step is to ask yourself, what multiplies to AC and adds up to B? What multiplies to AC and adds up to B? Third step is that once you figure out those numbers, break up B into those numbers. Third step is to break up B into those two numbers. And then the fourth step is to factor by grouping. Okay, this is where we're at now, factor by grouping. So what does it become? Excuse me. Thank you. What do I take out? What do I take out? Go ahead, Isabel.
So from the first half, I took out 3W.
Did you do it in the same order I did it? Did you do 3W squared plus 2W?
No, I had the 2W and the negative 12W.
Okay, so, and that works. You get the same answer. You do get the same answer. But just based on what I've got here, what would come out of the first two? You're going to get the same answer then.
W.
Yeah, just a W. And what does that leave behind? In my case, not in your case. Don't forget looking at yours, look at mine.
3W plus 2.
Good. So Isabella did it the other way. I was going to ask, this is great that you did that. So at the end of the question for this one, I always ask, you know what? What if I had switched the order of these two? And used negative 12W plus 2W? Technically, it's still correct, right? And what you'll get is you'll get the factor that repeats itself twice to switch in the answer. And I'll show you that in a second, okay? And you probably see it already. In the second case, what would be the GCF over here? And remember, I need to get 3W plus 2. I need to be left with 3W plus 2 by taking something out of these two. What number comes out of both of these? What goes into both 12 and 8? Negative 4. I like it. He says negative. I like it. Why'd you say negative 4?
Because since you have to get 3W plus 2, you have to divide that. And then negative 3 to make them positive.
You gotta have this here to be positive, so that's why you took out this negative. Very good. So the idea here is that your answer would have been a 3W out here and a plus 2 out here, and inside the parentheses repeating itself would have been W minus 4. Okay, so if you did this the other way that Isabella mentioned by by changing your B values, it is absolutely correct and just as good. It's up to you to choose. It doesn't matter. So our answers are W minus 4. Oops, I'll write it this way. Are 3W plus 2 and W minus 4. And again, it doesn't matter which way you write it because multiplication is commutative. Okay, because multiplication is commutative. It doesn't matter. So switch these order. Switch the order of these two. It makes no difference. More on AC method. You were going to ask before, but we did this. You sure?
Yeah.
Okay.
I was just asking before.
That was factor by grouping, yep. Other questions on AC method? I want to get to the next thing. All right, let's go to the next one. This is called square of sums. We're going to look at square of sums here. And if we look at the square of sums, what we're recognizing is a pattern. That's what I want you to pick up on. This is a pattern. That's all it is. You do not need to use this rule if you can physically factor things. But it could be very useful later on to make a quick factoring change in the middle of a problem. Pick up on the thing here. If I have an example where I have, like, say, x plus 2 and the whole thing is squared, right? For example, like this, x plus 2 and I square it, what does that become when I square x plus 2?
X squared plus 4x plus 4.
And the 4x is really taking double the product of this. What's the product of 2 times x is 2x. Double that, you get a 4x. And that's what this is saying right here. It's double the product of those two values themselves. Double that product. And where's the 4 coming from? The 4 is coming from squaring this 2 here. That's b squared at the end. And then the a squared itself is just x squared. So the reasoning behind this is that we can pick up on easy factoring techniques. For example, look at the here. A is the easy example to start with. What would A factor into? What would A factor into?
The quantity of t plus 4 squared.
Yeah. This factors in a t plus 4, or, as Valentina said, the quantity, well done, t plus 4 squared. Now, that's a pretty easy one because you can factor that by just inspection, by looking. When we get to parts B, C, and especially part D, it gets a lot tougher, right? What would B become? Tell me what B is. What is part B? Maura?
U minus 5 squared.
Yeah, the quantity, u minus 5 squared. Again, do it out. u minus 5 times u minus 5, right? We would get u squared minus 5u minus 5u plus 25, which would still give you that. So what are we picking up on? Let me show you something besides the way you see it with the variables is not as easy. With numbers, it's really easy. Take the square root of this number here. It is?
4.
Double it. It's always going to work out that this is going to work out to be that value, provided there's a 1 here. Now, let's look at an example a little bit later we're going to have to see, but let's start with this one. Square root of this is going to be a 5, right? 5 times the u is 5u, double that, you get 10u. The minus sign is just carrying over. So part C is not too bad either. Part C looks tough, but if we continue with the same pattern, part C is not too bad. Any ideas for part C? Who knows their squares? What's 6.25 really? What number is 6.25 squared? Some number squared is 6.25. What is that number? Anybody know? What's the square root of 625? The number is 2.5 because the answer would be 25 there, yeah. So this turns out to be w minus 2.5 squared. And if you're not sure of that, write it out. W minus 2.5, w minus 2.5. And when you FOIL it out, you'll end up getting w squared minus 2.5w minus 2.5w, which is what gives you the minus 5w. And then 2.5 times 2.5 will give you 6.25.
So if you find the square of the c value,
Square root.
the square root of the c value, and then double it to see if it equals the b value.
Then this will always work, correct. But Maura, that's for parts A, B, and C where there's no A value. Look at part D now. Part D is going to be a little trickier, okay? Part D is a little bit trickier. Part D is a little bit trickier. Here's how we do part D. Ready? Take the square root of the C value. Take the square root of the C value. Take the square root of the A value. So we have 3 here, and we have a 2 here. Multiply those two things together. 3 times 2 gives you 6, and then double it. You get 12 here, right? So this is another case where your answer is going to be 2p plus 3 quantity squared. And go ahead and FOIL it out. And what are we doing? We're recognizing that this 9 becomes the 3. The square root of this 4 becomes the 2. 625 rooted becomes this. 25 rooted becomes this. 16 rooted becomes this. It's working out every time. It's the last one is the most confusing one, though. Okay, we have to think about the fact that when you FOIL this out, you're going to get 6p when you multiply these. Right? You're going to get a 6p, and then you get another 6p. When I say multiply it out, I'm saying just FOIL these out. If you're not sure. First term gives you 4p squared. Inner and outer give you the same thing, right? This will give you the 12p that we had here in the middle. So your way of checking that this factoring technique works is what Maura was mentioning. You square root C and A, though, both. Okay, you square root C, you square root A. This is 3, this is 2. 3 times 2 is 6. 6 times 2 gives you 12. That is true. So this, by default, has to factor into this. And this always comes from the square root of this and the square root of this. Okay? It's a technique. It's not something that you have to use every time, but it is something that can be useful down the road, especially if the problems become more complex than this. Okay? Especially if they become more complicated. Let's finish with example 4, which will leave us probably very little time for now. Let's finish with example 4. Factor the following of these. So looking at the first one first, what's the problem right away you notice? What do you recognize?
Well, it's out of order, but
So what would be useful to make it order?
put it in order.
All right. Okay, then what would be useful next, probably?
Oh wait, hold on. I forgot what I was gonna say. But you could just do basic method.
No.
Multiply by -4.
Careful, there's not an equation. We can't multiply stuff right now. Is there an equation anywhere?
We'll factor out.
Thank you. Factor out a -1 instead. Okay, please recognize this. A lot of you will do what Maura said. It said multiply by -1. This is not an equation anymore. It's an expression that we're factoring. We can't just multiply both sides by something. And now we can factor, though. What numbers multiply to negative 8 and add up to negative 2? Multiply to negative 8 and add up to negative 2. Multiply to negative 8 and add up to negative 2. Okay, negative 4 and positive 2. Try it. Multiply these two numbers, you get negative 8. Add these two numbers, you get negative 2. How about part B? What numbers add up to 4 and multiply to 3? Or sorry, multiply to 4 and add up to 3.
Negative 4.
Negative 4 and?
1. Oh, negative 12.
Doesn't work, right?
Yeah.
Okay.
Negative 1 and 4.
Negative 1 and 4, but that multiplies to give you negative 4. We want positive 4, right?
Oh, negative 1 and 4. Oh, wait, it's next.
No, but you're on the right track. So what are you recognizing? All of those possibilities don't seem to work, right? So what can we say about this kind of a problem?
It's already factored.
Yeah, it is not factorable any further, okay? There are no values, so no numbers multiply to positive 4 and add up to positive 3. It's impossible. Because Helen just went through all the possibilities. It's all 1s and 4s, right? Or 2 and 2. So this cannot be factored further. So if you get to the point where you get an equation and you have a quadratic that can't be factored further, you just stop. You don't have to go any further. Don't force it is what I'm saying. I purposely put this at the end because by the end of this lesson, everybody thinks we can factor everything. And not everything can be factored. Okay, not everything can be factored. Hey, in the last section, in 4 or 5, there was also stuff about sum and difference of cubes. Okay, if you didn't for some reason do your homework and you're behind on videos, you got to get caught up. But if you're not sure about what I'm saying, that's what that means. But if you want help on that, today's the day to come. Okay, an hour after school today or tomorrow morning at office hours. Either one. Okay, please don't wait till Thursday after school. It's either, again, today after school, tomorrow morning, or Thursday, but that's late already.
If I miss some homeworks and I submit them over this break, is that okay?
They're still marked as late, but they'll be accepted, but they're late, yeah. Sebastian, this is from your line of best and stuff, right? I gave you. So tomorrow you and Regina are going to make up this quiz, 3:08 to 3:10. Okay, come by after school if you want help on it. I didn't even give you guys your quizzes back. I was going to have you look at them real quick.
Do you know what baseball says?
Do I know what?
The workouts for baseball.